Hello everyone, this is Mr. Steinman here for another guiding video for this first semester final review, which covers Unit 3, Systems of Linear Equations. So for the first example, we got to figure out how to graph these. So what I would recommend is we list the slope of the first equation, which is negative a half, y-intercept equal to 3, and then the 3 halves is that's what m is equal to, and then the b for that second one is equal to negative 5. So we can start graphing by looking at the b's here. 3 and a slope of negative 1/2 would bring us down 1 and right 2. So really this graph would look somewhat like this. That's the first equation, so that's line 1. Now for line 2, we started at b equals negative 5. And then our slope is 3 over 2, so 3 up and 2 right, so go 3 up, 2 right. And there's that. And now we graphed 2 lines. The simplest way we can graph any point that's only on line. We can say any point that's only on line 1, but I think the easiest one to do is the y-intercepts respectively. So 0, 3 for the first one, 0, negative 5 for line 2. So we can see those are clearly only on those lines. A point on both lines, there's only one answer to that, and this would be 4, 1, which is that intersection point right there. And then the point on neither line, it's pretty simple. We can just say 0, 0. You could pick something else if you wanted, as long as it's on neither line. So now for question 2, let's identify slopes and y-intercepts respectively. Alright, and then graph respectively. So we got a b of negative 6. We got to take our slope 2 up and 1. And remember, 2 is equivalent to 2 over 1, right? We could just say that's the same thing, right? So rise 2, up 1, right 1. So this is what our graph should look like there, and so on and so on. And then for the other equation, b is negative 1. The slope is positive 1/3, so you go up 1, 3 to the right. Quickly see that our intersection point is pretty visible, which is good. A point only on line 1, I just recommend choosing the y-intercepts. So 0, negative 6, 0, negative 1. And the point on both lines, there's only one point on both lines, and that would be 3, 0, the point where they intersect. The point on neither line, you can again say 0, 0, but other accurate points are welcome as well. Now, number 3, it's worded differently, but it's essentially asking the same thing. So we got slope and y-intercept. Let's list those respectively. So let's graph then. The first one, negative 6, go up 4, 7 to the right. Our graph looks somewhat like this. And then for that next one, negative 1, y-intercept, we go down 1, 7 to the right. So we can list those intercepts, the y-intercepts again, just for simplicity's sake. Solution to both is that one point where it intersects. That would be 7, negative 2. Not a solution. We can also say the origin 0, 0 is not a solution. So that's the first side here. Let's go on to the second side. So the second side is, first it's asking us to determine it's a solution of one or both or none of the equations. So what we'll be doing is just testing that 3, 8 into each of the equations. So we're going to have to ask ourselves, is 8 equal to negative 2 times 3 plus 16? 8 equal to negative 6 plus 16? We can already tell that this is clearly not equal to 8. So we know it's not a solution to the first one. How about the second one? 8 is equal to 7 halves times 3 minus 17. 8 equals 21 over 2 minus 17. I can already see clearly that the answer is no. It does not equal to 8. So it's a solution to none of the equations. How about that second one, though? Plugging it in, we get negative 3. Is negative 3 equal to negative 2 times 4 plus 16? Is negative 3 equal to negative 8 plus 16? No, it's not. So y1 is, again, not a solution. For y2, is negative 3 equal to 7 halves times 4 minus 17, which we would say that's going to be, is that equal to 14 minus 17? Yes, it is. So we're good. We can say that is a solution to y2, but not y1. So that for the next one, why don't we say we're going to plug in our negative 2. Is negative 2 equal to negative 2 times 9 plus 16? Is negative 2 equal to negative 18 plus 16? Yep, it is. So we can say it is at least a solution to y1. For y2 is a solution. Negative 2, is that equal to 7 halves times 9 minus 17? So is negative 2 equal to 63 halves minus 17? I can already say with confidence that it's no. So it is just a solution to y1. For number 5, compare the slope and the y-intercept of the following systems of equations, then identify the number of solutions. So remember, the key here is that we remember what warrants a certain number of solutions. So let's just write it down here. Same slope, same y-intercept means infinite solutions. Different slope means one solution. And same slope, different y-intercept that would equal 0 solutions, no solutions. So let's take a look. We got slope of 5 and negative 5 respectively, 10 and negative 10 respectively. Because we already know they have a different slope, by that alone we can say this has one solution. The second one, 7 over 3, 21 over 9. Y-intercepts are the same. Are the slopes different or are they the same? Well, 7/3 is actually equivalent to 21 over 9 when reduced. So it is the same slope and same y-intercept, same line, meaning that the solutions are infinite.
Good morning, Mr. Study.
Good morning. So then we got here 1.5, 3, 3 halves, 3. Again, we reach this point where 1.5 we know is equal to 3 over 2. So the number of solutions again is infinite because it's the same line. Here we got the same slope, but we got different y-intercepts, -1 and 1. So that would mean there are no solutions for that. All right, we're going to move on to page 4 here. Page 4. Now for page 4, converting to slope-intercept form. So for this case, we want to find y by itself. That's the simple goal here. Then we got to figure out number of solutions based on what we find there. So let's convert here. For that first one, let's subtract 2x from both sides. And you get 3y is equal to negative 2x plus 6. Divide both sides by 3, and you would get y is equal to negative 2/3 x plus 2. So that is our first of two equations. If we do the same thing to this one, add 4x to both sides to get that y by itself. Negative 6y is equal to 4x minus 18. And we divide both sides by 6. Y is equal to 4 over negative 6 would equal negative 2/3. So negative 2/3 x plus 3. And look at that, we've got two equations. Same slope, different y-intercept. Different intercept. That means there are no solutions to this one. But when we look at this one here, let's convert again. We're going to add that 9x to both sides. You get negative 3y is equal to 9x minus 10. And then we can divide both sides by 3. Y equals negative 3x plus 10/3. And then for this one, subtracting 3x from both sides, you get negative y is equal to negative 3x plus 4. You divide both sides by negative 1, you get y equals 3x minus 4. So just by the fact that we have a positive 3 slope and a negative 3 slope here, we can quickly see that this is going to be a different slope automatically assumes one solution. One solution. And then this one's solving the system of equations. This we would use elimination for these ones. Well, we got ourselves a pretty quick fix here because that's our elimination candidate right there. So when we add them together, 5x plus negative 3x equals 2x. These cancel out. 39 plus negative 29 equal 10. Divide both sides by 2. X is equal to 5. Then you plug in x is equal to 5 into equation of choice. I would choose the first one. 5 times 5 minus 7y is equal to 39. You get 25 minus 7y equal to 39. Subtract 25 from both sides. Negative 7y is equal to 14, so y would be equal to negative 2. So x is equal to 5, y is equal to negative 2. For this one, we can eliminate these guys, right? When we add it up, these cancel. 6y plus negative 5y is equal to y. It's convenient. So therefore y is equal to 1. Perfect. But now we got to plug in our y equal to 1. Let's choose the first one. Negative 4x plus 6 times 1 equals 34. So negative 4x plus 6 equals 34. can subtract 6 from both sides. Negative 4x equals 28, and x would equal negative 7. So x equals negative 7, y equals 1. That would be that third page. Now go to our fourth and final page. Fourth and final page here. Now we're going to solve each system of equations. We need to multiply at least one of these. So when I look at this, what appeals to me the most is eliminating these x's, because I could multiply this one by negative 3 to cancel them out. So if I do that and rewrite the equations, then I get negative 3x plus 15y equals 87. And then just keep that one the same. But now I found I can eliminate that when I add. So 15y plus 6y equals 21y. These cancel. 21y would equal 87 plus negative 18 would equal 60. No, that's negative 87. That should be negative 87 from the start. So that's what threw me off there. Negative 87 minus 8 plus negative 18, that would equal negative 105. And then we got a nice and neat division there. Y would equal negative 5. So let's plug in that negative 5 as y into, I'll say that, let's do it the first one. The second equation sounds the best to me. And then we got 3x plus 6 times 5, negative 5, equals negative 18. 3x minus 30 equals negative 18. You add 30 to both sides. You get 3x equals 12, and x would equal 4. So that is our solution for that first one there. 4 comma negative 5. And then for this one, I've already found that we should eliminate these y's, because look, we could just multiply this by 2. Let's write this one as is. And this one, when you multiply it all by 2, negative 6x plus 2y equals 42. You add this to both sides. Oh, this looks cancelable. 4x plus negative 6x would equal negative 2x, which equals negative 32 plus 42 is equal to 10. So x is equal to negative 5. So we can plug in that x is equal to negative 5. We can choose the second equation, why not? We could choose either one. Negative 3 times negative 5 plus y equals 21. So 15 plus y equals 21. So therefore, y is equal to 6. Y is equal to 6. But that concludes the video, and I hope this helped and that this prepares you fully for the test on Wednesday.